Hi, in this video, we will move on to talk about charges moving in magnetic fields. Now we've already seen that when the current flows through a wire in a magnetic field, there is a force acting upon the wire. Now this current is a flow of electrons. So it won't be difficult to imagine that these individual charges each experience a force when moving inside the magnetic field, as we're going to see in figure 4. In this figure, the force due to the magnetic field is acting at right angles to the direction of the motion. So the path of the moving charge is curved. Now the equation of the force acting on the charge is F is equal to B Q V, where B is the magnetic field, Q is the charge, and V is the speed in which the object is moving at. Now, in which direction does the force act? The force is always at 90 degrees at both the current and the field. So you can use Fleming's left-hand rule to find its direction. Now applying the left-hand rule on the example we have seen for a positive and a negative charge. The magnetic field is pointing into the screen. And so, point your first finger into the screen. The direction of the positive charge indicates the direction of the current, and so point your second finger into the right. And here your thumb will be pointing upward, and that's the direction of the positive charge. Now, can we get the result for the negative particle? A negative charge moving to the right has to be treated as a positive charge moving to the left. And so applying the left-hand rule, we get that the movement of the charge is downward.